Now we are given 4 first-order formulas, and we have to prove that the fourth formula, the conclusion formula, is a logical consequence of the other 3 formula as premises. And we have to apply resolution for that. Okay, as you know, resolution only works with CNF formulas. Therefore, we have to translate all those formulas into CNF. So let's start with the first one. It's easy to translate this formula to CNF. We only have to eliminate the implication like that. And that's it. This is already in CNF. So let me just add this as a clause, the first clause in our clause set for all x, not ox or tx. And notice that it is a universally quantified formula, which is completely okay, because in CNF, universal quantifiers might appear, and only universal quantifiers are allowed to appear. And therefore, because only universal quantifier can appear in CNFs, we can even, how to say, not display the universal quantifier, because we actually know that this variable x is bound by a universal quantifier. So this somehow simplifies the representation of the clauses. Okay, let's continue with the second premise, which can be easily translated to CNF for all x, not dx or not tx. And yeah, in a similar way, we add this as a new clause, but we won't display the quantifier. So the second clause is not dx or not tx. The next premise is a existentially quantified formula. Actually, it's almost in CNF. The only problem which occurs is this existential quantifier in predicate logic. A CNF formula must not contain any existential quantifier. We have to eliminate it. You know how to do that. It's called Skolemization. We have to introduce a brand new constant, a Skolem constant, and substitute it into all the occurrences of the bound variable. So basically, we just eliminate the quantifier in front and then substitute a brand new constant, let's say C, into both occurrences of x. Okay, this is a CNF. This CNF consists of 2 clauses. The first clause is D of C. The second one is I of C. Okay, and then let's translate the conclusion formula to CNF, but not exactly. As you know, we are about to prove logical consequence now. Therefore, first, we must negate the conclusion formula. So basically, the formula, what we have to translate into CNF is negation exists x, ix, and not ox. Okay, how to translate this formula into CNF? Where we definitely have to apply one of the De Morgan laws, which turns the quantifier into a universal quantifier. And long story short, the result will be for all x, not ix or ox. And this is already in CNF, so this is going to be the fifth clause, not I of x or O of x. Okay, this is our input clause set. It consists of 5 input clauses. And now let's run the resolution algorithm on this over this clause set. So of course there are different ways to do it, but now I will pick 2 clauses. I will pick clause number 4 and 5 and generate a new clause as you can see, in clauses 4 and 5, you can find I of C and I of X. They are not the same. However, we can and we should unify those two atoms, and they can be, of course, they can be unified. The unifier is X substituted with C. This is the unifier we need. Since we found the unifier, let's unify those two clauses. I just show you what the result would be. Well, of course, here instead of X, we would get C, and also here. So the fifth clause after unification, after the application of the unifier, is not I of C or O of C. And then if after we resolve the two clauses, we get the resolvent O of C, like that. Okay, let's keep going. In the next step, I don't know, let me pick clauses 2 and 3 and generate a new clause, clause number 7. Okay, 2 and 3. In a similar way, we have to construct a unifier which substitute X with C, and then the unifier is going to be not T of C. Then in the next step, let's pick clause number 7 and resolve it with clause number 1. And again, the unifier will be X substituted with C, and the resolvent is going to be not O of C. And I think now we can see where we are going to. We are picking clause number 6 and 8. Clause number 6 is O of C, clause number 8 is not O of C. So of course, if you resolve those two clauses, then you get the empty clause. And I would like to highlight the fact that we don't need any unifier for that. So we derive the empty clause, and you know what it means. It means that the input clause set is unsatisfiable, which also means that the original conclusion formula is a logical consequence of the premises.